Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series, where we are discussing chapter wise concepts. Also we are discussing chapter wise PYQs. So today we are going to discuss the electric charges and field chapters PYQs. We have already completed all the lectures from this chapter. If you have not seen them, you can go and check in the playlist of our channel. There is a dedicated playlist for KCET physics series, where all the videos that we have done already is uploaded, and every day 9 PM we are uploading a new video. And if you want to get the updates, you have to join our WhatsApp channel. The link for the WhatsApp channel is given in the description below. And without delaying any further, let us dive into the PYQs. We will start from 2023 PYQs. 2024 entire question paper is solved and it is available on our website. You can go and check that series if you want. 2024, 2023 and 2022 individually as a whole paper is solved. Here we will start from 2023 question papers and we will move on and we will solve top 30 questions from this chapter, and also there will be a homework for you that you have to answer and mention the solution in the comment below. I will discuss that in our next video. So let's start with the first question. Electric field at a distance r from an infinitely long uniformly charged straight conductor having linear charge density lambda is E1. Another uniformly charged conductor having same linear charge density lambda is bent into a semicircle of radius r. The electric field at the center of this E2 is then. So you have to remember that the wire was infinitely long. Okay, the wire was infinitely long. Okay, so even if you bend it to form a semicircle, that semicircle will also be infinitely long. So what will happen is that you can consider this as a straight line. So infinitely long wire, you bend it to make a semicircle, so its radius of curvature will also be infinite, and you can say that the electric field will remain constant, that is E1 equals to E2. Okay, a cubical Gaussian surface has side of length A equals to 10 centimeter. Electric field lines are parallel to x axis as shown. Let us look into the diagram. The magnitudes of electric field through the surfaces ABCD. So magnitude of the electric field of the surfaces through ABCD, this is ABCD surface, as you can see, is 6 kilonewton per coulomb, and EFGH, this is EFGH through this is 6, this is 9. Okay, and kilonewton means you have to convert it into newtons, right? So 10 to the power of 3, this is the Newton per coulomb. Respectively, the total charge enclosed by the cube is, take epsilon to be value of epsilon is given 9 times 10 to the power minus 12, and you are asked to find the charge enclosed inside this cube. So first we have to find the flask. Okay, input flask phi in equals to whatever the electric field in times area ABCD. Okay, that is the flask in. Okay, flask is area times electric field. So electric field in is 6 times 10 to the power of 3, and area of ABCD is basically the square of the surface, that is a square. So if this is a, then it is a square. Now what is a? A is 10 centimeter. So remember, it is centimeter, not in meter, so you have to convert it. 10 times 10 to the power of minus 2 whole square, that is the area. Okay, here this 10 times 10 to the power minus 2 whole square is the area, right? Now let us simplify this. 6 times 10 to the power of 3 times, let me make this simplified. 10 times 10 to the power of minus 2 is basically 10 to the power of minus 1, right? So minus 1, and then if you do the whole square of entire thing, it will be whole square of the entire thing, so it will be 10 to the power of minus 2. Okay. So, this entire thing will become 10 to the power of minus 2. So, what is the resultant flask? Flask is 6 times 10 to the power of 3 minus 2, that is 10 to the power of 1, that is 10, that is 60. Okay, unit is SI unit. We are not bothered about unit because we are solving MCQ questions, we are solving numerical questions. So, we are not very interested in units. As long as they are all in SI units, all the units are converted, that is fine for us. Now, let us find the phi out. Phi out is what? 9 kilonewton, right? 9 kilonewton, 10 to the power of 3, same a square, that is 10 to the power of minus 1 whole square, and it will be 90. Okay. So, this will be 90. So, previously it was 60. So, this one will be 90. So, total flask, net flask is phi out minus phi in, right? That is the net flask, that is 30. Okay. Now, what we know that net flask is charge enclosed divided by epsilon naught, right? So, Q enclosed is equals to 30 epsilon naught. Now, the value of epsilon naught is given 9 times 10 to the power of minus 12. Okay. So, it will be 270 times 10 to the power of minus 12, or we can write this as 0.27 times 10 to the power of minus 9, or 0.27 nanocoulomb. Okay. Let us check the options. So, 0.27 nanocoulomb is the option. Now, remember that it is net flask is phi out minus phi in, always. Okay, whatever is going out minus phi in is the net flask. Now, if this value was negative, then the charge would have been negative, right? But this value is positive, that is why this charge is positive. Okay. Simple problem, not very difficult. Only thing you need to know how you to calculate the flask through each of the surfaces. Okay. Now, let us move on. A positively charged glass rod is brought near an uncharged metal sphere which is mounted on an insulated stand. If the glass rod is removed, the net charge on the metal sphere 0. Very simple question. There was a metal sphere, it was standing on an insulated sphere. Now, you brought a glass rod positively charged. Okay, when the glass rod is here, it will induce negative charge here, positive charge here, but as soon as the glass rod is removed, they are not touching. So, as soon as the glass rod is removed, okay, this plus and minus, they will come back together and they will eliminate each other, and only the neutral glass rod will be left. Only the neutral glass rod will stay here, right? So, net charge is 0. Now, let us move on to the next problem. A tiny spherical oil drop carrying a net charge Q is balanced in still air with a vertical uniform electric field of strength 81/7 pi times 10 to the power of 5 volt per meter. When the field is switched off, this is an extra 7 here. The drop is observed to fall with the terminal velocity of 2 times 10 to the power of minus 3 meter per second. Here G is 9.8 meter per second, viscosity of air is 1.8 times 10 to the power minus 5 Newton second per meter square, and the density of oil is 900 kilogram per meter cube. The magnitude of Q is. So, what is the thing? The oil drop is falling. Okay, initially it was balanced, that means whatever its mg was, that was balanced by QE. So, initially we can write E QE, that is sorry, not E, QE was initially equals to mg, right? Now, when the electric field is switched off, the drop is observed to fall with the terminal velocity. So, when the electric field is switched off, then it started falling with terminal velocity. That means all the forces in this object is still balanced. All the forces is still balanced. So, we can write that same force, that whatever is the viscous force 6 pi eta RV should be equals to mg. Okay, so viscous force, now viscous force is acting upward and the weight is acting downward, so 6 pi eta rv equals to mg. So now we can compare this equals to QE. I don't know why I am writing QE. Okay, now this is the force. Now what we have to do, we have to find the charge Q. So Q is equal to 6 pi eta rv divided by E. Now remember that here the radius of the oil drop is not given. Okay, so radius of the oil drop is not given, so first we will try to calculate the Q in terms of the value R, then we will try to figure out how we can calculate the R, because density is given. So from there we will get another equation. So let's first try to find the value of Q in terms of R from this given equation. 6 pi times eta is given as 1.8 times 10 to the power of minus 5. Okay, R we don't know yet, and V is given 2 meter per second, 2 into 10 to the power minus 3 meter per second. 2 times 10 to the power of minus 3 meter per second, everything is in SI unit. Electric field is given by 81/7 pi into 10 to the power of 5. Okay, so pi cancels. Now what we have to do, we have to simplify if possible, right? I don't see any immediate simplification. So what we will do, we will just write down this value 6. It will reduce 0.2, 9 to the 18, so 9 9s are 87. It will reduce 2 to the 6, 3 3s are 9. Okay, now we will get 2 to the 4, 4 to the 8, but 0.8 because there is a decimal here. So 0.8 times 10 to the power of minus 5 minus 3, and this will go up and it will become minus 5 again. So 10 to the power of minus 13. Okay, and in division there will be a 7 also. This 7 will go up, divided by 3, right? So it will be, so Q we got, there was a R that we are not yet calculated. So Q will be equals to 56 5.6 divided by 3 times 10 to the power of minus 13 R. Okay, so you cannot compare these values or you cannot guess the values, because all the values given here are very close. So you cannot guess it from here, you have to solve the rest of the problem. Okay, so let's try to solve the rest of the problem as well. Now we also know that QE was mg, right? QE was also mg. So initially this value was given, initial at the beginning it was balanced, so the weight was balanced by the electric field. So QE is mg. Now we will use that concept here. Okay, so what we will do, we know that QE is unknown, E is given, we are writing E as well right now, and M is 4 by 3 pi r cube times rho, that is 900, right? Mass is volume times density. Okay, now volume of a sphere, it is a spherical drop, right? Spherical, for a sphere it is 4/3 pi r cube, right? And rho is given, so we can put that value times g. So g is 9.8. Okay, so here, from here also we will get another value of q, or you can find the value of r and you can substitute in this equation to calculate the value of r. Okay, so now q times E is 81/7 pi times 10 to the power of 5 equals to 4/3 pi r cube times 900 times 9.8. okay, so pi cancels on both side, and we can see that. Okay, let me put this value of r here, it will simplify the things. So the value of r is 5.6 times 10 to the power of minus sorry, the r value is, let me substitute the value of q here. Okay, q's value is 5.6 times 10 to the power of minus 13 divided by 3 r, okay, times 81 by 7 times 10 to the power of 5 equals to 4/3 r cube 900. okay, for time being assume this 9.8 as 10, even though they have asked you to use 9.8, for simplicity we will use this as 10 and we will use the 0. Now what we have got, let me rewrite the equation again. 5.6 divided by 3 times 10 to the power of minus 13 r times 81 by 7 times 10 to the power of 5. See, this problem is little longer because it takes some time to solve, but don't worry, you will get some question where this you can make up this time. So but initially don't attempt this question, initially try to attempt the questions which is easy to solve. okay, now this 3 cancels, r cancels, we get r square here, you get r square. Right, now we have to simplify everything and try to find what is the value of r, right. So 0.8 times 81 times 10 to the power of minus 13 plus 8, that is 10 to the power of minus 8, okay, equals to 4 times 9000 r square. okay, so r square is equals to 0.8 times 81 divided by 4 times 9000 times 10 to the power of minus 8. okay, so it will be 0.2, right, and it will be 1000, it will be 9, so it will be 9 times 2, let me make it 2. So if I make it 2, it will be 10 to the power of minus 9, and there will be a 1000 in division, so it will be 10 to the power of minus 3. So r square will become r square equals to 18 times 10 to the power of minus 12, right. Now then r will be 3 root 2 times 10 to the power of minus 12. So you have calculated the value of r, okay, and we will use this value of r to calculate q. okay, so q was 5.6 divided by 3 times 10 to the power of minus 13 r. Sorry, I made a mistake here. it is square root, right? So 3 root 2 and there will be square root of minus 12 as well. Minus 12 will become minus 6, right? So 3 root 2 into 10 to the power minus 6. How I realized? Because all the options given in the question was 10 to the power of minus 19. So it cannot go more than that value, basically less than that value. So from that intuition I realized I made some mistake here and I corrected that. Okay, now 3 cancels, so 5.6 root 2 times 10 to the power of minus 19. Now what is the value of root 2? 5.6 times 1.4, okay, times 10 to the power of minus 19. So you can take this value as 1.5 approximately, and you can write it will be 5.6 plus 2.5, that is 8.1, around 8.1 times 10 to the power of minus 19. Okay, that is the charge. So from the given option, it is 8 times 10 to the power of minus 19 coulomb. Okay, so just let me explain this once more, how I calculated this value. Okay, so 5.6 times 1.5. Okay, I assume this is the value of root 2 for simplification. Now 1.5, right? So 1 means 5.6 is there, and 0.5 means half of that, that is 2.8. So 2.8, that means it will be 4.8. So 8.4. Okay, so it will be 8.4, approximately 8.4, but there are a lot of approximations that we have done. First of all, we have increased G to 10. If you remember, we increased G to 10, also we increased 1.4 to 1.5. So considering everything, the actual answer should be less than that, and only one option is correct from the given option. So only one option is correct, that is option D here. Okay, now let's move on. An electric dipole with dipole moment 4 times 10 to the power of minus 9 coulomb meter is aligned 30 degree with the direction of uniform electric field of magnitude 5 times 10 to the power of 4 Newton per coulomb, the magnitude of torque acting on the dipole. So this is a easy question, right? So previous one was difficult question. So there are some previous difficult question, there are some easy question. Okay, only thing you need to remember that when you are calculating torque, it will be sin theta, not cos theta. So what is the value of P? P is given by 4 times 10 to the power of minus 9, and electric field is given by 5 times 10 to the power of 4. Okay, as sin theta, theta value is aligned at an angle 30 degree, so sin 30 degree. Okay, so this is a simple problem. 5 4s are 20, 10 to the power of minus 5, sin 30 is half, so it is 10, so 10 to the power of minus 4. Okay, this is the torque. So correct answer is option B. So this is a simple one formula, one answer question. Okay, so in CET there are multiple mixed concept questions like the previous one, where it was little difficult and it will definitely take 5 minutes, 6 minutes to solve that problem. First of all, you have to understand that problem, then answer that. But there are some problems which you can solve like in 30 seconds. So if you have practiced this, if you remember P sin theta formula, then you can easily solve it. And if you are studying properly, you should be able to remember these easy formulas and you will be able to answer them. Next, 4 charges plus q plus 2q plus q again and minus 2q are placed at the corners of square. 4 charges plus q plus 2q plus q and minus 2q are placed at the corners of square ABCD respectively. The force on a unit positive charge kept at the center O is. Now if you read the question, you don't need to start calculating immediately. They have only asked you along the diagonal AC, 0 perpendicular to AD along the diagonal BD. So you have to only draw the diagram and understand the force, direction of the force. Okay, so first quickly draw the diagram. Okay, so what are the sequence? Plus q plus 2q, then another plus q, then minus 2q. Okay, now if you see the force on the unit positive charge kept at the center, so center is where is the center, where the diagonals meet, right? So this is the center. Now unit positive charge, this will be repelled by, so start with the first charge, okay. So this is repelling, getting repelled in this direction, and this charge is getting repelled in this direction. For due to this charge, it is getting repelled in this direction. Now this charge and this charge are same in magnitude, so they will cancel each other. Okay, let me use a different color. So this charge is getting repelled in this direction, right, and this are opposite in the magnitude, opposite in the sign, but same in magnitude, so they will cancel each other. So you can simply say there is no force in this direction, okay. So these charges will cancel, only charge that will left is this charge. Now what is the direction of this charge? This is getting this is positive charge, right. So positive charge means it will getting attracted, so it will getting attracted in this direction, so magnitude will remain same. Now A, B, C, D, so the direction is B to D, from B to D. So the along the diagonal BD, that is the correct answer. Okay, any doubt, mention in the comment below. Easy question, only you need to draw the diagram, quickly understand the direction and then answer it. A charged particle of mass m and charge q is released from the rest in an uniform electric field E, neglecting the effect of gravity. The kinetic energy of the charged particle after t second. So simple question, we know that the kinetic energy, simple formula of kinetic energy is half mv square, okay. And remember that here time is given. If distance was given, instead of time, if distance was given, we would have used the concept of potential, but since time is given, we will use mechanical formula, that is half mv square. Remember this is thing clearly, that if time is given, we are going to use mechanical thing, that is half mv square. If displacement is given, then we will go to the potential formula, work done is equal to q times v. From there we will calculate the energy, that energy will give us the value of kinetic energy, because it is completely converted into kinetic energy. So we can calculate from there. We will solve that kind of problem also today, so don't worry about that. Now here, so what is the force? Force on a charged particle in an electric field, q times E, right, that is the force. If there is a force, there is an acceleration, right. So acceleration is given by QE divided by m. So we know that final velocity is initial velocity plus at. Now initial velocity is 0 because it starts from the rest, okay, released from the rest. So v equals to basically at, right. Now we will put that value here, half m at whole square. Now what is a? A is this, so we will put that value as well. Ek is half m QE by m t whole square, that is half q square E square t square by m, right. One m will cancel, m square will be in the denominator and m will be on the numerator, so one m will cancel, and simplified this 2 I can write this here, okay. So q square E square t square divided by 2m. So the correct answer is this one, okay. So this is the correct answer, E square q square t square divided by 2m is the correct answer. Now next problem, which of the following statement is false in the case of polar molecules? You have to read all the options and you have to eliminate whatever is incorrect. Centers of positive and negative charges are separated in the absence of external electric field. Obviously it is for polar molecules, it is obviously separated. Centers of positive and negative charges are separated in the presence of external electric field. So if it is separated in internal electric field, definitely it will be separated for external electric field as well. Do not possess permanent dipole moment, obviously they possess permanent dipole moment. So this statement is false, so this statement is actually incorrect, and what they have asked you to find the incorrect statement, so this is the correct answer. So incorrect is the correct, right? Good idiom. Ionic molecules, HCl is an example of polar molecule. HCl is obviously an example of polar molecule. This is also correct. So only incorrect statement is C. Okay. Now, a 2 gram object located in the region of uniform electric field E equals to 300 Newton per coulomb I cap carries a charge Q. The object is released from at rest x equals to 0, has a kinetic energy of 0.12 joule at x equals to 0.5 meter. Then Q is, so as I said, there is a problem where this is a similar problem, electric field is given and you are given with the distance, okay, from it starts from x equals to 0 and it reaches x equals to 0.5. So displacement is given, delta x is given. Delta x is given, delta x is basically 0.5 minus 0, that is 0.5, and if you see the electric field is 300 Newton per coulomb I cap, that is it is in the direction of x axis, right? I cap means in the direction of an x axis. If there was a negative sign, it would have been opposite side of the x axis. Now the charge is also moving from origin towards along the direction of x axis. So what type of charge it is? Charge is moving in the direction of electric field. So obviously it is a positive charge, okay. So we have understood the polarity of the charge, so only the positive answer we will take. Whatever answer we will get at the end, we will only consider positive charge. Now we know that electric field can be written as delta V by delta x, magnitude wise, right. So delta V by delta x is the electric field. So delta V, this is also a mixed concept question, delta V is equal to delta x times E, okay. So change in potential, what is the change in potential here? 0.5 times E, E is 300, right. So 300 times 0.5, 300 times 0.5 means 150, right, 150 volts. Now what we have to do, we have to calculate the work done. Work done, we know that work done is basically Q times delta V, right, that is the work done, that is the concept of potential. So Q is not known, capital Q, they have given capital Q, I am writing small q, so let me correct that. Capital Q times V is the work done, that is the kinetic energy, because entire energy is here kinetic energy, right. So we can write Q times 150 equals to kinetic energy is given 0.12. So joules, or Q equals to 0.12 divided by 150, okay. Or let me simplify this, well, let me write this as 12 times 10 to the power of minus 2, okay. Decimal is complicated here, so I will just simplify it. So it will be 3 4s are 12, 3 5s are 15, okay. Now this is done, 4 by 50 times 10 to the power of minus 2. Now we have to simplify it little bit more. So Q is equal to, we will multiply with 2. So 8 by 100, 8 by 100 10 to the power of minus 2. So this will go up and it will become 8 times 10 to the power of minus 4, or 800 times 10 to the power of minus 6, or 800, okay, 800 microcoulomb. So correct answer is 800 microcoulomb, okay. If you are still struggling with 10 to the power, how we can convert 10 to the power from numerator to denominator, denominator to numerator, and then by adding extra minus, and we can increase the zeros. If you still are struggling with these steps, then you have to practice this kind of problems more and more, so that you can overcome this issue. Now let's move on to the next problem. Electric field due to infinite straight uniformly charged wire varies with distance r, as we know that electric field due to uniformly charged wire is given by 1 by 4 pi epsilon naught 2 lambda by r. So here lambda is the line charge density. So we can see that this is basically proportional to 1 by r. So correct answer is option B. A copper rod AB of length L is rotated about end A with a constant angular velocity omega. The electric field at a distance x from the axis of the rotation is. Now this is a controversial question. Okay, what they are saying that if we rotate a copper rod, there will be an electric field, which is not entirely true, but maybe there are some issue here, maybe there are some electrons here at the edge, there will be some electrons. So we can find the electric field due to that electron. Okay. Now if the copper rod is rotating in a length is L, okay, and one end, this end is fixed, suppose this end is A, this end is B, this is fixed, and one electron is located at the other end, and we can find the electric field due to this electron at a distance, some distance x from this. Okay, and what will be the first of all, what we have to find is the centripetal force acting on this electron from the axis of the rotation, they have said. So it will be, so this is the axis, right? Some distance x we are trying to find the electric field. So what we will do, first we will find the centripetal force. Centripetal force is mv square by r, okay, or m omega square r, that is the centripetal force. Now if we keep a charge here, an electron here, what will be the force acting on this? That will be E times E. So when the rod reaches here, the electron on that rod at distance x, okay, it will experience this force, and this is the expression for centripetal force. Here instead of r we have to use the term L, right, m omega square L. So electric field will be E equals to m omega square. A copper rod of AB length L is rotated about an end A with the constant angular velocity omega. The electric field at a distance x from the axis of the rotation is. So what is the thing? There is a rod and it is rotating about one end is fixed, suppose this is A, this is B, okay. The length of the rod is given L, and they have asked you to find the electric field at some distance. Suppose this is the axis of rotation, and they have asked you to find the electric field at some distance x. Now suppose there is an electron located at this position, and the charge on the there are two forces acting on this electron. One force is the centripetal force, right, and another force is the force due to the electric field, right, force due to the electric field. Now if it is in equilibrium, then this electric field, the force due to this electric field will be converted into centripetal force. Now what is the centripetal force? Centripetal force, this L is not required, only x is sufficient, right, because we can consider only the equilibrium for the electron located at a distance x from the axis. So centripetal force is m omega square x, right, this is the centripetal force. Now what is the electric force? Electric force is E times electric field. Now if this is in equilibrium, this electron is in equilibrium, the system is in equilibrium, then these two forces should match, that is E times E will be m omega square x, that is capital E, equals to m omega square x divided by E. This is the answer. Okay, so m omega square x divided by E, so option A is correct answer. Now let us move on. When a soap bubble is charged, the radius remains same. The radius may increase or decrease. Radius increases if radius decreases. So when a soap bubble is charged, suppose this is a spherical shape, right? So when you give it a charge, what will happen? Charges will reside on the surface, because inside a soap bubble only air is there, it is hollow from inside. So all the charges will stay in on the surface. Now we know that same charges repel each other, right? So positive will repel each other, that will it will experience a outward force. So they will try to accommodate as much surface area as possible, so that everyone is distant apart, right? So what will happen? The radius will slowly increase, so that all the charges will try to attain a equilibrium position where all the charges are farther more far from each other. So, slowly what will happen, the bubble will increase in its radius. So, radius will increase. Okay. Now, let us move on. The electric field lines on the left have twice the separation on those in the right as shown in the figure. The magnitude of the field at A is 40. So, magnitude of electric field A is 40, okay, and the separation, whatever separation is here, suppose the x is separation here, then this is 2x separation. Okay. Now, what is the force on 20 microcoulomb charge kept at B? So, they have kept a 20 microcoulomb charge here. What is the force on this charge? They have asked you. Now, remember the property of electric field lines, closer the field lines, stronger the electric field is, and it is directly proportional, right. So, if this is 2x, this is x, then this electric field will be half that of this electric field, right. So, electric field here at B will be 20. If this is 40, this will be 20 because they are now spaced out twice. So, twice means it will be half of that, right. So, electric field at B is 20. Now, we can calculate the force here. Force is given by Q times electric field. So, Q is given as 20 microcoulomb and electric field is 40 volt per meter. So, it will be 800 times 10 to the power minus 6 or 8 times 10 to the power of minus 4. So, you have to practice these problems more and more. This is a very simple problem if you know how to answer this question. As you can see, this is a very simple, very less time taking problem. Now, let us move on. A point charge Q is placed on the corner of a cube of a side as shown in the figure. What is the electric flux through the surface ABCD? So, they have placed a charge here and they have asked you what is the flux through this surface. Now, if you see that inside that cube there is no charge. So, inside that cube no charge means the cube does not enclose any charges, the charge is on the surface. So, charge is on the surface does not matter. We know that electric flux through a closed surface only depends on the charge which is it encloses, right. So, on the surface does not matter. So, the flux should be 0, that is answer will be 0. An infinitely long thin straight wire has uniform charge density of 10 to the power of minus 2 coulomb per meter. What is the magnitude of electric field at a distance 20 centimeter from the axis of the wire? We already know that electric field due to a straight long wire is 1 by 4 pi epsilon naught. I always ask you to remember this formula. In the book they have cancelled 1, 2, which is difficult to remember, but if you remember like this you will never face any difficulty because 1 by 4 pi epsilon naught value we always know. Okay. So, 1 by 4 pi epsilon naught is 9 times 10 to the power of 9, 2 lambda, lambda is 1 by 4. So, 2 times 1 by 4 times 10 to the power of minus 2 divided by r, value of r is 20 centimeter. 20 centimeter means 20 times 10 to the power of minus 2. Now, 10 to the power of minus 2, 10 to the power of minus 2, they are same. So, it will go up and cancel anyway. So, we cancelled it and it will become half. So, half times 9 times 10 to the power of 9 divided by 20, right. So, what we will get? We will get 9 divided by 4 times 10 to the power of 8. So, 1 0 we have reduced because there was a 1 0 in the division. Now, 9 by 4 is almost 2 point something, right. So, 4 to the 8. So, it will be 2 point something, and if you see the answer, okay, times 10 to the power of 8. Now, if you check the options, only one option is correct, that is 2.25, which is the closest. So, if you do that, you will get 2.25, but in the exam hall, in the time of rush, you don't need to calculate, you just get the approximated value and check the answer which one is closest. Okay. An electric dipole is kept in a non-uniform electric field. Non-uniform electric field, remember that it will generally experience if it is an electric field, if you keep a dipole, it will always experience a torque, also it will experience a force. Because it is non-uniform, that means the torque which is acting on this. So, non-uniform electric field means, Okay, suppose this is positive, this is negative, this will experience a force in the direction of electric field, this will experience a force in the opposite direction of electric field. Non-uniform means electric field is not constant. Okay, not constant means the resultant of these two forces will not be 0, there will be a resultant force acting on some direction, whichever direction, whichever side it is more, so it will experience that force, and it will also experience a torque because some component is same, right. So what will happen, it will move like this, it will move like this, it will rotate and it will move. Okay, so that's why it will experience a force and a torque. Now a certain charge 2q is divided at first into two parts, q1 and q2. Later the charges are placed at certain distance. If the force of interaction between the two charges is maximum, then now let us solve this in mathematical way. I hope you have studied about maxima and minima, how to calculate that. So we will use that concept. So there is a analytical way as well, sorry, quantitative way as well, but quantitative way is may be appearing vague and you may not get the answer if some other values is given. So we will use direct analytical method. q1 plus q2 is 2q, that is given, right. So they have divided it into two parts. Now q2 will be equals to 2q minus q1. Now what is the force between these two charges? Now force between these two charges is k q1 q2 by some distance r square, right, or k q1 2q minus q1 divided by r square, or we can write this as k 2q q1 minus q1 square divided by r square, right. So this is the force. Now how to calculate the maxima for charge q1? Force will be maximum. For maximum force, df dq1 must be 0, dy dx is 0 for maximum value, right. You can do the double order derivation also to check whether it is a maximum or minimum. If you have studied that in your calculus, please mention that in the comment below that I have completed that. If you have not yet completed that, that also you mention in the comment below that I am yet to complete that part. So for maximum and minimum, this is the maximum value. For maximum we have to calculate the first order derivative and see if it is 0 or not, but if it is said it is maximum, then we will just simply put it 0 and calculate the value. Now we are differentiating with respect to q1, and remember that k is constant, q is given constant, r is arbitrary, so we are not considering r. For any r it has to be true, so we will only differentiate q1. So now if you see k by r square, it is constant, I am writing it outside. Now 2q q1, so the 2q is constant, this is x, so dx by dx, that is 1 minus x square. What is the differentiation of x square? X square differentiation is 2x, right. So in this case 2q1, and it will be equals to 0. Okay, so this is the condition for maxima. This is the condition for maxima. Now we will simplify this further. Okay, and we can see that 2q minus 2q1 equals to 0. This is not 0, right. So only this can be 0. So q equals to q1, right. You simplify it, or q by q1 is equals to 1. This is the ratio. Okay, so q by q1 is equals to 1. So if you divide 2q charge, force will be maximum only when they are equally divided. That is, one has capital Q charge, another one will also have capital Q charge. So that is a quantitative way to discuss about this, but if you know the mathematics also, you can solve it. Okay, don't worry. Next, the force of repulsion between two identical positive charges when kept at a separation of r in air is f. Half the gap between the two charges is filled by dielectric slab of constant 4. Okay, then the new force of repulsion between those two charges become. So what is the problem? We have two charges, okay, q1, q2, and they have said half the gap, not the entire gap. Entire gap one we have discussed in our class lesson, right. Here they have said half the gap is filled with the dielectric constant of slab 4. Okay, now how can we calculate this? So, we already know that if you have missed our lecture, please go and check the lecture. We have solved this kind of problem. We know that the force with dielectric slab is given by 1 by 4 pi k epsilon naught times q1 q2 by r square, right? Or we can write this as 1 by 4 pi epsilon naught q1 q2 by root 2 epsilon root k root k r whole square, right? So, this is the formula that we know. Now, this distance is called equivalent distance for dielectric medium. Now, dielectric medium was only initial, suppose the distance was suppose 2r at the beginning. So, what was the force? Force was k q1 q2 by 2r whole square initially, that is 1 by 4 k q1 q2 by r square. Now, half of that is r is now this distance is r, okay, and rest of the r is in vacuum still. So, what will be the force now? The force, new force will be k, you have to remember this formula, q1 q2 by this root kr, this only root is under root, k is only inside the root, r is outside, plus r whole square. So, this is already in free space and this is only in dielectric, right? Now, what is the value of root k? Root k is root 4, that is 2. So, we can simplify this as k q1 q2 divided by 2r plus r whole square, that is, what is the value of 2r plus r? That is 3r. Now, 3r whole square means will be 9r. So, it will be 1 by 9 k q1 q2 by r square. So, initially it was 1 by 4, now it is 1 by 9. So, what is the ratio? So, ratio will be 4 by 9, right? 4 by 9 f, 4 by 9 f. So, option is option D. Initially it was 1 by 4. So, if you divide f dash divided by f, so that 4 will go up and it will become 4 by 9 f. Okay, very important concept. Many students actually ignore this concept and try to think, okay, KCET is very easy, but this is also a part of the KCET, okay, and this concept comes multiple times in the previous year. So, let us see one more problem. The magnitude of point charge due to which the electric field 30 centimeter away has a magnitude 2 Newton per coulomb will be. So, this is the question. This type of questions give the impression that KCET is easy. It is easy, okay, 60 to 70% it is easy, but rest 30% it is not easy. For that you have to study hard, okay, and if you want a detailed explanation how this is done, I can make a complete video on that only for that dielectric part, and I can upload that. So, mention that in the comment below, sir, I want a detailed explanation for that part. Okay. Now, the magnitude of point charge, say point charge is q, okay, and they have said that at a 30 centimeter away the electric field is given by 2 Newton per coulomb. They have asked you to find q. We know that electric field is given by k q by r square. K is 9 times 10 to the power of 9, q we do not know, electric field is given 2 and r is 30 centimeter. So, 30 times 10 to the power of minus 2 whole square, okay, or 2 equals to 9 times 10 to the power of 9 times q divided by 30 square means 900, 10 to the power of minus 4, okay. So, it will become, it will cancel, it will become 100. So, 100 and 10 to the power of minus 4, 10 to the power of 9 times q divided by 10 to the power of minus 2 right, because this will become minus 2, 100 times 10 to the power minus 4, and now it will go up, so it will become 10 to the power of 11 times q, and it was 2 on the left hand side. So, q will be equals to 2 times 10 to the power of minus 11 coulomb. Okay. So, 2 times 10 to the power of minus 11 coulomb. Okay. Now, let us move on. 3 point charges of plus 2q and minus 4q are placed at the corners of ABC of an equilateral triangle ABC of side x. So, equilateral triangle side x, okay, each sides are x, and they have placed say 2q minus 4q. Now, they have asked you to find the magnitude of the electric dipole moment of this system. Now, it may look like little complicated, actually it is not so complicated. Mathematically it is little longer, but problem you can answer, nothing that sort of difficult. So, what you have to do first, you have to divide this minus 4q charge into two parts. Okay, one say minus 2q, another will be minus 2q. Now, you can say this is a dipole and you can say this is a dipole. Okay, these two are the dipoles, and dipole moment due to this is in this direction from negative to positive, and dipole moment due to this is in this direction, right. So, you can consider them individually as dipole, and you know the direction of dipole. So, along the triangle we can say this is the direction of dipole moment, this is the direction of dipole moment, and the resultant we can calculate using the vector magnitude, or whatever method you want, you can use the vector method. Both of them will be equal in magnitude. You can see that any one of the dipole moment, magnitude of dipole moment, both of them are 2q to q, right, and distance is x. So, dipole moment is charge times distance. So, it is 2qx is the dipole moment for any one of the dipole, right. Now, what is the angle between them? This is a equilateral triangle. So, this angle should be 60 degrees. Now, you can use the parallelogram law to find the magnitude. So, P equals to square root of the net P, square root of P square plus P square plus 2P square cos theta cos 60. Okay, A square plus B square plus 2AB cos theta, right, that is the formula. So, here both of them are same P, right, both of them are P. So, it will be A square plus A square. So, P square plus P square, and 2AB, both of them are A. So, 2A times A, that is 2A square, right. So, you can write this as 2P square plus 2P square cos 60. Cos 60 means what? Cos 60 means half, right, cancels. So, it will be root 3 P square, sorry, root of 3 P square or root 3 times P. So, the dipole moment, the net dipole moment will be root 3 times 2 qx or 2 root 3 qx. So, correct answer is option A. Okay. This is a simple formula I have used, or you can use one more formula, that is you can divide this into components, and that is also fine, but I am not discussing that. This is the simplest direct approach. Okay, there you have to be little bit careful, you might make some mistakes and your answer will be incorrect. So, this is the direct approach, you can directly use this vector addition formula and solve this. 4 times 10 to the power of 10 electrons are removed from the neutral metal sphere of diameter 20 centimeter placed in the air. The magnitude of electric field at a distance 20 centimeter from its center is. So, this is very careful, be very careful. It might seems that because there is no charge inside. So, they have neutral metal sphere of diameter 20 centimeter, diameter is 20 centimeter. Okay. Diameter is 20 centimeter means the radius is 10 centimeters. So that is the main catch here. Okay, radius is 10 centimeter. Now they have asked you to find the electric field at a distance 20 centimeter from the center. It is not on the surface. It is not on the surface. So sometimes people may get carried away and say, okay, this is the electric field may be 0 just inside the surface, that means electric field may be 0, but it is not. You have to use the formula that where entire charge is considered at the center, we have to calculate the charge first, then we can use the simple formula E equals to kq by r square. Simple formula that we are going to use. First we have to calculate the q. Now this many electrons are removed, so what is the charge? Q is equal to Ne. N is 4 times 10 to the power of 10 to the power of plus 10 times 1.6 times 10 to the power of minus 19. So the charge is 4 times 1.6 times 10 to the power of minus 9. It will be 64, and since there is a decimal, it will be 6.4 times 10 to the power of minus 9. Okay, so we have calculated the charge. Okay, so we have calculated the charge. Now we have to use this formula to calculate the electric field. So electric field is 9 times 10 to the power of 9 times q is 6.4 times 10 to the power of minus 9 divided by 20 centimeter. 20 centimeter means 20 times 10 to the power of minus 2 meters whole square. So 9 cancels. Okay, 9 times 6.4 divided by 400 divided by 10 to the power of minus 4. Now calculate this value, and before me answer this question. Okay, so it will be 100 and it will be 1.6. So we have done this multiplication for nothing, right? So that's why I sometimes say don't calculate before you reach to the conclusion. 9 times 1.6 times 10 to the power of minus 4 times 100, that is 10 to the power of minus 2, it will be 10 to the power of 2. Okay. Now if you see, this will be, what is the value of this? Let me do this way, 9 times 1600, right? 9 times 1600, because this will become 100, 9 times 160. 9 times 160. Okay, so 100 times 1.6 is 160. Now how we can multiply? 9 times 100 is 900 and 60 times 9 is 540. So 900 plus 540. This is a shortcut trick of multiplication. If you don't know, you have to learn it. Okay, so 14. So what I have done, I have divided 160 into 2 halves. Okay, one is 100, another is 60. So first I multiplied 9 with 100, then I multiplied 9 with 60, and then I just added them. This is the simplest way. Another way to multiply, right? You can simply either you can use the multiplication table, use it, or you can simply, this is the easy way to remember. 9 into times 900 and 9 6 are 54, so there is one more 0, so 54 0. So you can simply add them. Okay, this is one of the another quickest way to do the calculation. So more you practice this, better you will be for your KCET exam. Two spheres of electric charges plus 2 Newton Coulomb and minus 8 Newton Coulomb are placed at a distance d apart. If they are allowed to touch each other, which is the now distance between them, to get the repulsive force of the same magnitude as before. So plus 2 and minus 8 initially placed at a distance d. Now nanocoulomb is there, but I am not considering that because the problem is not exactly calculative in nature. We will compare that, so constants will cancel. So what is the initial force? Magnitude 2 times 8 by d square, right? So 16 k by d square was the initial force. This is remember that we have ignored the nanocoulomb charge because that will cancel. Now once you touch them, once you touch them, what will happen that they will distribute the charges. Now, since they are same spheres, nothing is said about their size, so they are identical spheres. So, once you touch them, each of them will have equal amount of charge. So, what is the total charge? Plus 2 minus 8, total charge is minus 6. Now, that charge will be divided into two spheres. So, that will be minus 3 and minus 3, both of the spheres will now have minus 3 charges. Now, the new force will be k times 3 times 3 divided by a new distance, say x square. Now, what is our target? Our target is to make this force equals to force, right? So, we can write that 16k by d square equals to 9k by x square. Okay, k cancels. So, we can see that x equals to, now we have to find the value of x. 16x square equals to 9d square, okay, or x square equals to 9 by 16d square, or x equals to 3 by 4d. Okay, so be careful what you are writing, what is your answer, be careful, it will be 3 by 4d. Okay, let us move on to the next problem. If Ax and Eq represent electric field at a point on the axial and the equatorial line of a dipole, if the points are at distance r from the center of the dipole for A, then we know that axial is twice that of equatorial. So, correct answer is this. Okay, axial is twice that of equatorial, also it is negative sign because axial is in the direction of dipole, whereas equatorial plane is opposite to that of the direction of dipole. Now, let us move on. Electron of a mass m, charge E, falls through a distance h meter in uniform electric field E, then the time of fall. Very interesting question. So, what is the question is that a charge mass m and charge E falls through a distance h in an uniform electric field. Now, electric field, only electric field is given. So, we are not considering gravity, it is falling. Okay, what is the force acting on it? Force acting on it E times E. Okay, so only electric field, no gravity is involved, right? So, the force acting on this is this, right? Now, what is the acceleration? Acceleration is force divided by mass, that is E by m, right? Now, they have travelled some distance h. Now, initially it is just, you just dropped it. So, imagine you have just dropped this pen from my hand, then what will happen? The distance travelled will be half gt square, right? If I drop this, the distance travelled will be half gt square, here it will be half at square, and they have asked you to find the time. Simple problem, only they have branded it in terms of electric field instead of gravity. Okay, so T is basically 2h by a square root. So, 2h by g, you have calculated that, right? 2h by g for simple when you drop some object from height, right? So, 2h by g, 2h by g is a is E by m. So, it will be 2hm divided by E. So, 2hm divided by E, that is the answer. So, correct answer is option A. Now, let us move on. If there is only one type of charge in the universe, then electric field ds area vector is not 0 on any surface. E dot ds could not be defined. E dot ds is infinite if charge is inside. E dot ds equals to 0 if charge is outside, Q is equal to q by epsilon naught if charge is inside. So, we know that Gauss's law does not say anything about what is the type of charges, how many charges are present. Only thing it states that if charge is inside, the electric E dot ds is q by epsilon naught, and if charge is outside, then electric E dot ds is 0. So, correct option is option D. Does not matter how many type of charges are there. We know two types of charges are here, positive and negative, but it does not matter how many charges are there. as long as Gauss's law is obeyed, we know that Gauss's law obeyed does not depends on how many types of charges are there. If it was so, then it would have been mentioned that since there are 2 types of charges, then this law is valid, but there is no such thing is there. Gauss's law is universal law, it is valid, so you can still use the law. 2 spheres carrying charges plus 6 mu c and 9 mu c separated by a distance d experiences a force of repulsion F when the charge of minus 3 microcoulomb is given to both the spheres and kept at the same distance before the new force of repulsion is. So, this is a simple question. First 6c and 9 microcoulomb. So, 6 microcoulomb times 9 microcoulomb, okay, k by r square was F initially. Similar type of problem, you will see that this was the almost same as that 2 charges kept in contact then separated, almost same problem. Only thing they have mentioned is here they have introduced a minus 3 charge. So, this is the F new force is k 6 minus 3 9 minus 3 same distance r square. Okay, so, k what was the initial value? 54k, right, 54k divided by r square. Okay. Now, what is the new value? 3 times 6 18, 18k by r square. Now, what is the ratio? F dash final by initial, always find the ratio final by initial, that was what we are trying to find. So, final was 18 times, initial was 54 times. So, it will be 3 6 18, 9 6 54, 1/3. So, F dash is F by 3. Okay. So, F by 3 is the correct answer. You have to try to solve this kind of problem more and more and practice yourself. Okay. Pick out the statement which is incorrect. Again, incorrect statement, remember they have asked you to find the incorrect statement, not the correct one. The electric field lines from closed loop, obviously not. So, this is the correct answer. First line, first option is obviously is our correct answer for this question, because electric field lines does not form closed loop, it is a open loop. Only magnetic field lines forms closed loops, right. Field lines never intersect, they will obviously they never intersect. The tangent drawn to a line on the force represents the direction of the electric field, correct. A negative test charge experiences a force opposite to that of the direction of electric field, obviously this is also correct. Now, question number 28, the angle between dipole moment and electric field at any point on the equatorial plane. So, in the equatorial plane the electric field is in this direction, if you remember, and the dipole moment is in this direction. So, the angle is 180 degrees, okay, not 90 degrees. Someone mentioned that the angle is 90 degree in comment, but that actually that is not the correct reason. Also, the angle is not 90 degree, the angle is 180 degree. A spherical conductor of radius 2 centimeter is uniformly charged with 3 nanocoulomb. What is the electric field at the distance 3 centimeter from the center of the sphere? So, a spherical conductor radius 2 centimeter, okay, charged with 3 nanocoulomb, okay. What is the electric field at a distance 3 centimeter from the center? It does not matter what is the shape, simple problem, Gauss's law, that all the charges can be concentrated on the center as long as it is outside the center. So, we can write electric field is basically kq by r square, okay. So, 9 times 10 to the power of 9, q is given, what is q? 3 nanocoulomb, q is 3 nanocoulomb. So, we just simply put the values minus 9, okay, and r is 3 centimeter, that is 3 times 10 to the power of minus 2 whole square. Now, remember that in some cases they might trick you and they will give you a distance which is actually less than that of the radius. So, in that case electric field will be 0. If they give you some value where electric field is given such a way that you are asked to find the electric field inside inside the conductor. In that case, electric field will be 0 because all the charges residing on the surface. Now 10 to the power 9 into the minus 9 cancels, and we can write 9 times 3 divided by 3 square is 9 times 10 to the power of minus 4, 9 cancels. So, this will be 3 times 10 to the power of minus 4. Okay. So, 3 times 10 to the power of minus 4, that is, this is the correct answer. Okay. It is volt per meter cube. This is also volt per meter cube. Okay. Volt per meter. Sorry, volt per meter. Okay. This is the answer. Now, last question of the day. What is the nature of Gaussian surface involved in the Gauss's law of electrostatics? So, Gauss's law says that the surface must be a vector quantity and the direction of any surface is always perpendicular or normal to the surface, right. Now, time for 2 homework problem. Please mention the answer in the comment. Homework problem number 1, pause the video if you want and mention the answer in the comment below. Okay, I will not read the question, you just read the question and answer the question in the comment below. Okay, I will see you tomorrow's lecture where we are going to discuss about electric potential and capacitance chapters in previous year questions. A lot of capacitor based questions are there in the previous year questions. So, we are going to solve everything, all the important of 30 questions from that chapter as well. And if you have not yet joined our channel, subscribe to our channel and join the WhatsApp group. I request you join there, and to get all the latest update, please click on the notification icon in our WhatsApp channel, so that whenever we are posting a new video, you will get a notification. All the this note I will try to provide in form of PDF as well. So, I will see you tomorrow.